Hello my dear friends, now we can start our new topic, that is seepage analysis. If I talk about the seepage, so we should understand what is seepage. I always discuss the water flows from high direction, I mean to say from high head to low head, means from high energy to low energy water will flow like this. So flowing of water is a permeability, flowing of water is a seepage. Then what is the basic difference between seepage and permeability? So let me clear, the permeability is the property of this soil which allow the flow of water through its body, through its interconnected voids, that is called permeability. So permeability is a property and seepage is the process. Seepage is occurring because of permeability. If the soil is impermeable, seepage will not occur. Seepage means flowing of water, it is a process, it is the action, clear? So because of permeability, seepage may occur. If soil is impermeable, seepage will not occur. If I talk about the rock, rock is having zero pores, no pores, less permeable rock, hard rock. If I give amount of water, it will not be draining out through the rock surface. So seepage is not possible through the rock, in the rock, okay. So here seepage is the process which occurs because of permeability. Here, and water will always flow from high head to low head. So here I can write the name of the topic, that is your seepage analysis, okay. Seepage analysis. So this is your seepage analysis, and now we should discuss about the seepage analysis. You see here, suppose I take one soil sample, something like this. Let me consider one soil sample, something like this. This is one soil sample. This is the entry or the starting point of the soil sample, okay, and one piezometric tube, suppose we have inserted somewhere here. This is the exit point of the soil sample, and suppose one piezometer we have inserted somewhere here, something like this, okay. So here in this piezometer I can say this is the available head, and somewhere here in the second piezometer, in the last piezometer, we have head somewhere here. Definitely from high head to low head water will flow. And this is your soil sample, and this is the axis of the sample. The length, let me consider, of the soil sample is suppose L. What happens if I talk about the datum line? If I talk about the datum line, then if in the question datum is mentioned, consider the datum here, here, here. If they mention clearly about the datum line, then that you can consider. Otherwise, if datum is not mentioned, then you people should consider the datum at the tailwater. This is called tailwater. So somewhere here we can consider the datum, okay. So this is my datum line. Now you people should ask me, sir, when you explained the Darcy's law permeability topic, that time you have taken the datum somewhere here. Yeah, because of my interest I have taken, no problem. If in the question they mention about the datum, that datum you can consider. If they don't give any information about datum, you should consider the datum at the tailwater. Clear? Just because of my interest, I was taking the datum here in the permeability, no problem. In the permeability topic also, you can consider the datum at the tailwater. Clear? So generally a tailwater datum line should be considered. So this is your datum. All the pressure measurements shall be done from this datum line. Now here this is suppose your point A, this is your point B. If we talk about this one, we have inserted the piezometer at the point A. So what we are getting, we people get the pressure head at A somewhere here. This height is the pressure head at A. If I talk about this point B, so here we get the pressure head something like this, pressure head at B. Okay, pressure head B we have, pressure head at B, A we have. Now if I insert one piezometer in between A and B anywhere, suppose here I insert one piezometer somewhere at any point, you can insert the piezometer. So water will rise and it is rising in this pattern. So water will rise up to here suppose. Okay, so water will rise up to this height. So if you want, I can hatch these tubes, means water is rising. Here also, if you insert the piezometer in the sample, water will rise up to here, water will rise like this. So here let me consider the water is rising up to the head, pressure head at C, pH, something like this. Okay, this is the pressure head at C. Now we people should understand the meaning of datum. Now we have discussed about the pressure head. Let's talk about the elevation head. Elevation head will be measured from the datum. So what is the elevation head here, point A? So this is the elevation head from here to here. This is your elevation head ZA. Since it is below the datum, means ZA will be negative, because above the datum value will be positive, below the datum value will be negative. This is your point C. Let me consider this is your point C. That's why I have written pressure head at C. If I talk about the head here, elevation head, then from the datum we are measuring suppose ZB as the datum, and this is also negative. At the Z if I talk about, at the point C if I talk about, then it will be also negative ZC. Clear? So everywhere we have measured the datum and all the points A, B, C are below the datum line, means they are negative. One thing we people can see here, many times in the permeability topic also we people have discussed that your total head in pipe flow is equal to velocity head plus pressure head plus elevation head. This is in the pipe flow actually, pipe flow, where the discharge was very high, so the velocity was very high, so V velocity head we can consider. In the pipe flow, discharge is too much, is large amount of discharge will flow through the pipe, so the velocity will be very high, so velocity head we should consider. But if I talk about here in geotechnical engineering, the total head will be equal to pressure head plus elevation head. Velocity head we are ignoring, so I can write in geotechnical engineering. Geotechnical engineering means when the water is flowing through the soil. So here velocity will be very less because the discharge is very less. So total head is pressure head plus elevation head. This total head can be written as a piezometric head also sometimes. Piezometric head, or it is also written as sometimes hydraulic head. Hydraulic head. Total head is also called piezometric head, is also called hydraulic head. Piezometric head is the sum of pressure head plus elevation head. Clear? So sometimes what happens, sometimes I can write about the piezometric head. Piezometric head is always measured from the datum. From the datum. From the datum means, piezometric head means what? Piezometric head means water column height. That should be measured from the datum actually. Is known as piezometric head. Suppose if I say this is the soil sample, something like this, and for 1 minute you can consider this is your datum, and somewhere here I have inserted the piezometer. This is the point A suppose, and the rise in water table is somewhere here. So from here to here this will be your pressure head, but this is not the piezometric head. Piezometric head shall be measured from the datum. So from the datum if you measure something, that will be called piezometric head. Piezometric head. So of course from the datum the point A is located at a ZA. So pressure head plus ZA, which is your elevation head, will give the total head, and this total head is nothing but your piezometric head from here to here. This is your total head. Elevation head plus pressure head, which is your piezometric head. So sometimes pressure head is called the piezometric head considering or the measuring from the datum, like that I can say. But all the time piezometric head is always measured from the datum. So if you measure from the datum, it should be called piezometric head. If you measure from the given point, that shall be called pressure head. Clear? So there is a basic difference like that. So total head is your piezometric head, and sometimes it can be called hydraulic head. Okay. Here let's calculate the total head or piezometric head at the hydraulic head here at the point A. Can we calculate? Yes, we can calculate. So at the point A, let's calculate the total head. So total head at A will be equal to pressure head at A plus elevation head at A. So total head at A, you should understand we have given what is the value of pressure head. Pressure head at A is denoted by pressure head at A, like this. So here I can write pressure head at A, and the elevation head given below the datum line. This is the datum, and it is given below the datum line, which is negative ZA. So I should use negative sign, minus ZA. So this is your total head at A, which can be denoted by small h. The hydraulic head, I can say hydraulic head at A is small h equal to pressure head at A minus elevation head at A. This is the hydraulic head. I am denoting by small h, means I am talking about hydraulic head, nothing but your piezometric head or the total head. Clear? So this is called your hydraulic head. This can be called as your hydraulic head. HA. Can I see this HA in the figure? Yes, this HA can be seen here in the figure. You see here, this is pressure head, and from this pressure head you subtract this much distance of negative elevation head. So from here to here, this value will be your, from here to here, this will be your HA, that is the hydraulic head. Am I right? Okay, so this is called HA, hydraulic head at A. In the same fashion I can calculate for this also. Let's calculate for C. So total head at C will be equal to pressure head at C plus elevation head at C. So total head at C will be equal to pressure head at C. How you can measure pressure head at C? You insert your piezometer and measure the pressure head at C, which is PHC. So you have measured. If I talk about the elevation head, so the point C is below the datum line, so this value ZC will be negative. So I can use the negative sign here, minus of ZC, something like this. Clear? So here this total head can be denoted as a hydraulic head, small hc, and it will be equal to pressure head at C minus elevation head at C. So this is what we have, hydraulic head. Okay, so this is also called hydraulic head, or also known as piezometric head at C. So can I see this value here? Of course, pressure head at C, this is the positive value, and below the datum ZC is negative. So from this value you can subtract this value, so this much you will be getting. So this much value is your, the value of hydraulic head at C. Clear? HC. So HA, hydraulic head available here is more than the hydraulic head available here at C. Means at A energy is high, available is HA. At point C energy is less, available is HC. Because at the point A there was a full energy. When the water covers the distance from A to C, some loss of energy of water occurs because of friction between water and soil solids. So the energy of water reduces. How much energy is reduced? From here to here, this much energy is reduced. Suppose HA is 50, HC is 30, so the 20 is the loss of energy. For example, HA is 50, HC is 30, so the loss of is 20, value is the loss of energy is 20. So like that we can have the, so this hydraulic head actually are showing the available energy in the water. Okay. Now let's talk about the total head at B. So we can have the total head at B will be equal to pressure head at B plus elevation head at B. So I can write total head at B is equal to pressure head at B minus, you see elevation head, this is the elevation head for the point B, and the point B is located below the datum line, so this ZB will be negative. So minus ZB I can write here, minus ZB I can write here. So here what is the total head at B? So you should notice pressure head at B and datum head at B both are same. You can see pressure head at B and the datum head or elevation head at B both are same. One is positive, one is negative, the value will become 0. So the total head at B energy is 0. So here I can say hydraulic head can be considered as here 0, because if you want I can write this is also ZB minus ZB. So here hydraulic head at B will become 0. Okay, so this is your hydraulic head at B. So if you want I can write this is your This is your hydraulic head. Okay, so hydraulic head at B is 0. Means we are measuring the energy with respect to this point. I am not telling the water has become water is having zero energy here. With respect to what water is having zero energy? With respect to this datum line, or with respect to this tail water. This is actually called tail water. Okay, this is actually called tail water. This one, tail water. So at the tail water, we people should consider, or I can show something like this. This is your tail water. So here at the tail water level, we should consider a datum line with respect to this. With respect to this, we have higher energy here, then energy is decreasing, and here it is reaching to 0. Getting my point? So with respect to this, actually here we have energy 0, here we have HSE, here we have HA. If I consider datum somewhere here, then some energy will be here, some energy will be here, and some energy will be here also. So depending upon the location of datum, hydraulic head will change. So taking the datum is a very sensitive condition. If in the question they give the value or they give the location of datum, then no problem. If they don't give, then you people should consider the datum at the tailwater level. Okay, it can be considered at the tailwater level. One thing people should notice here, it is this dotted line is connecting the topmost water level of all the piezometer. This is called piezometric surface. This surface is called piezometric surface. This line, this dotted line is the piezometric surface. Okay, so can I find what is the total head loss? Total head loss, can we find? Yes. So total head loss when the water covers the distance from point A to point B can be determined. So here I can write head loss. Total head loss will be equal to total head at A minus total head at B. So delta H can be written as total head loss can be written as hydraulic head at A minus hydraulic head at B. So total head loss can be written as small h. Let me write small h is the head loss equal to hydraulic head at A minus hydraulic head at B. So like that also we can write. So can I see this small h? Yes, of course I can see this small h. First thing you people should notice, what is the hydraulic head at A? And this is the hydraulic head at A. What is the hydraulic head at B? The hydraulic head at B is 0. So the head difference or the head loss will be equal to HA only. So here I can write the head loss is equal to head available at the hydraulic head available at the A also. Okay, this is your, this can be called difference in head. This H can be called head loss, or this head can be called head difference, or this head can be called can be called head causing flow or can be called head causing flow. Why head loss? Because total head A minus total head B, so head loss. Head difference, there is a difference in head equal to H. So you can see there is a difference in head. Here we have head here, here we have head here. So this and this, what is the difference? In the figure you can see the difference. The difference is equal to this one, HA. This line we are passing through this datum, so you can see the difference is HA, and this HA is coming equal to H only, right? So this is happening here when you consider the datum. This is the beauty actually. If you consider the datum here, the available head at A will become the head difference, because at this particular point your total energy is 0, because the datum is considered here only. That's why the total head is coming 0 here. If you consider datum somewhere else, total head here will not be 0, some value will be there. So that depends, okay? So that depends upon the location of your datum. But the final answer will be same. The values of total head, pressure head, elevation head may change, but the final answer which we are estimating, that will be same, okay? So generally authors suggest, geotechnical engineers suggest to consider the datum at the tail water, so the calculation become easy because head at the B becomes 0. So finally the available head at A will become the hydraulic head, will become the head loss, and will become the head causing flow. Head causing flow means, you see, if we have no head difference between point A and point B, water will not flow, because water always flow from high head to low head. Water will always flow from high head to low head, means the water is flowing from A to B, because at A we have higher energy, at B we don't have any energy. So this is the head which is causing the flow. Because of that flow is happening, that's why it is called head causing flow. Clear? So under this head flow is happening, under this head flow is happening, that's why it is called head causing flow. Clear? So this was your soil sample. If you want, you can write here also it is your soil sample. Otherwise you people can consider it is a hollow cylinder. Soil sample. Okay. So this was the picture. Now what we actually do here, we want to discuss the seepage analysis. But till now I have not discussed anything regarding seepage. We are discussing how to calculate the pressure head, total head and elevation head. So now come to the main point, seepage. What happens? As we know, water is flowing from high energy to low energy, high head to low head. The high head is available at the point A, lower head is available at the point B. Water has to flow from point A to point B. In between point C is also present, that is fine. When the water flows from A to B, so water is flowing from high energy to low energy. So when water flows from high energy to low energy from A to B, water will apply one pressure on the soil solids, because who is restricting the flow here? What are the obstacles present here in the tube for the flow of water? Solids are the obstacles. So the water which is flowing is exerting the pressure on the soil solid. So that pressure is called seepage pressure. This is not a static pressure, it's a flow. When the water is flowing, then only this pressure will act. If water is not flowing, it is in the hydrostatic condition, then the seepage pressure is 0. This will not occur. Only pore pressure occur. Under the static condition, the water exert the pressure is called pore water pressure. But when water is under the dynamic condition, means the water is flowing, then it will exert one pressure on the soil solid which is called seepage pressure. So there is a difference between seepage pressure and pore pressure. Pore water pressure is also applied by water. Seepage pressure is also applied by water. but pore pressure is applied in the static condition and the seepage pressure is applied in the dynamic condition, means when the water is flowing. What is the direction of this seepage pressure, sir? Tell me. So direction of seepage pressure or the direction of seepage force will be in the direction of flow. If the water is flowing in this direction, then force will be applied in this direction, means the water will apply the force or the pressure on the solids in this direction only. So in the direction of flow, pressure occurs, and this seepage pressure depends upon the available head. You people should ask me, sir, everywhere the seepage pressure is same? I will tell you no. Everywhere the seepage pressure is changing. The maximum seepage pressure will occur at the point where the maximum or the maximum head is available. Here we have maximum head at the point A, so the maximum pressure will be applied. Now the pressure which is applied at the A is very high. Now the water is flowing and the pressure is becoming less, and at the point B the pressure becomes 0 because the hydraulic head available is 0. So seepage pressure depends upon the hydraulic head. Let me write here, seepage pressure I can write when water flows through the soil, it exerts the pressure in the direction of flow, which is known as seepage pressure, Clear? It is known as seepage pressure. That means one more thing I want to write, this seepage pressure depends upon the available hydraulic head. Okay, depends upon the available hydraulic head. Now I can write the seepage pressure here, the formula I can write, seepage pressure is equal to available, I can write available hydraulic head into unit weight of water. Clear? So here I can write the final formula, seepage pressure is equal to available hydraulic head. I can write, suppose small h into unit weight of water, I can write gamma W. So this is the expression of your seepage pressure. If you ask me, sir, can you tell me what is the seepage pressure? I can write seepage pressure at A, I can write seepage pressure at B, and I can write seepage pressure, here I can write seepage pressure at C, and here seepage pressure at B. Can we write? Yes, we can write. So what is the available head here at A? It is HA. Of course it is equal to head difference, but it is HA. So HA is the available head. So HA into gamma W is the seepage pressure at the point A. What is available head here? HC. So HC into gamma W is the seepage pressure at C in this direction, in the direction of flow A to B. And at B, what is the available head? It is 0. So seepage pressure at the point B is 0. So here I can write about the seepage pressure at A. It can be written as HA into gamma W, HC into gamma W, and here I can write HB into gamma W, and HB is 0, so this value is 0. And one thing you should notice, which value is higher, HA, HB, HC, which value is higher? What is the available head? So the maximum available head you will find at the starting point of the flow, because full energy is available. So at the starting point of the flow, full energy H is available, then it is reducing to HC, and then it is reducing to 0. So here we have maximum head, that's why here we have maximum seepage pressure. Then here we have minimum pressure which is 0, and here we have intermediate seepage pressure at the point C in this file. So here if you want, I can write this is the maximum seepage pressure and 0 is the minimum seepage pressure, and here we have intermediate value. Clear? Now you should understand how it is depending upon the head. Definitely seepage pressure will depend upon the head. You can feel, suppose I'm a structure or something, I am a soil, suppose. One glass of water, suppose please throw one glass of water here. Can I flow with this water, one glass of water? No. Why? Because the energy is very less. Now one bucket of water is coming. Can I flow with this? Because seepage is occurring, one bucket, seepage is occurring. Can I flow? No. Because the seepage pressure is less. Seepage pressure is occurring, but I am not flowing because the seepage pressure is less. Now one big flood is coming of this much depth of water. This much depth of water flood is coming, or the river is coming, or the ocean, thick, this much depth of water is coming. Can I flow with this now? Can this water take me? Yes, this time it can take me. Why? Because the available head is more. So it will apply higher energy, it will apply the higher pressure on my body, that will be seepage pressure. This time it can take me with it. Clear? So here what I mean to say, if the available head is more, if the available energy in the water is more, water can flow easily and it can apply higher pressure on the sample, higher pressure on the obstacle, and if obstacle is not stable, having less strength, then obstacle can also flow with the water. So here soil should be stable, soil should have very good strength soil should have, so that because of this seepage pressure, soil solids should not flow with the water. Okay? Otherwise what will happen if the soil is loose, having less stability, having less stiffness, then when the water will come, water is flowing from high head to low head. When the water will come, with the water only soil will flow. Your structure may fail. Your structure is resting on the ground and below the ground soil is present. If the soil is flowing with the gravity water which is flowing underground water, if the soil is flowing with that, then there will be, after some time there will be no soil below the ground, your structure will settle down. Who will take the load of the structure? Because soil is not there, it is flown already, so the entire structure will get settled, your structure may collapse. So your soil should have stiffness, strength. Now how will you achieve that strength? By compaction. We will discuss in the next chapter, chapter number 3, we will discuss about the compaction, consolidation, stiffness, treatment. So many things may happen and so many things we can do also. Okay, so by increasing the effective stress of the soil, by compacting the soil, we can make the soil stiff, we can make the soil dense. Dense soil we want. So that's because of seepage, water, your soil solid should not flow with water. So okay, this is the seepage pressure. So can we convert this seepage pressure into the seepage force? Yes, I can convert. How? Let's see here. If I want to estimate seepage force, so seepage force is actually equal to seepage pressure into cross sectional area. So I can write cross sectional area. So here seepage force is equal to seepage pressure H gamma W. H is the available head. In most of the case, if you ask me, if you give me one soil sample and if you are asking, suppose in this case only, if you are asking me, sir, what is the seepage pressure, what is the seepage pressure, and you are not indicating the location. If you are asking me, sir, this is the soil sample, this is the length of the soil sample, tell me what is the seepage pressure, and you are not indicating me the location, whether I should calculate it B, C or A. So as a good civil engineer, where should I give the answer? B, C or A? Which will be my answer of seepage pressure? I always consider the worst condition. Which point is under the critical condition? Point B, point C or point A? Of course point A, because it is subjected to higher seepage pressure. So this is the dangerous condition, this is the dangerous point. So I should give the answer at A, that's it. If somebody is asking what is the seepage pressure, directly you tell H gamma W. H is the maximum available head. So here this is only the maximum available head, then it is decreasing. So where we have the maximum available head, there only we can estimate the seepage pressure. So seepage pressure, of course I am taking maximum value H gamma W. Of course this H is the HA. So cross sectional area, let me consider A. What is cross sectional area? Cross sectional area of the soil sample. This is the cross sectional area. From this point to this point, this is the cross sectional area. From this point to this point, this is complete cross sectional area we can consider. Okay, so once you consider this cross sectional area and the length of the soil sample is suppose L. So cross sectional area is A there, and what we people are doing, we are multiplying by L and dividing by L. So here what will happen, H, can I write H by L into gamma W into A into L, like this we can write. So H is the head difference, am I right? This H is the head difference, head loss or head causing flow. So this is head difference divided by length of flow path L. L is the length of flow path, which is equal to the length of soil sample here. Okay, so here I can write L is the length of flow path. So this value will be equal to hydraulic gradient I, this will be gamma W, I gamma W, and AL will be the volume of soil. Cross sectional area into length, L will be the volume of soil. So in this fashion we have calculated the seepage force I gamma W into V. V is the volume of the soil sample. Okay, so if you want we can estimate the seepage force per unit volume also. So I can write seepage force per unit volume, and it can be given as per unit volume means what? I gamma W, this is the seepage force divided by per unit volume V. So V to V is cancelled, finally we will be having I gamma W. So I gamma W is actually the seepage force in kilonewton in the direction of flow per unit volume. Okay, so seepage force will be always acting in the direction of flow. So I can write seepage force will be acting in the direction of flow. Okay, this is very important point. Suppose if I ask you the resultant force which is acting in the soil sample, how will you estimate? Suppose I take point 1, point A I take, or any other element, suppose I take this soil I have taken, what is the state of stress in this soil, means how many forces are occurring and how the resultant forces can be estimated, we can see here. You see this element I have taken. In this element, what is the vertical force acting here? Of course, because of self weight. So here self weight means, of course, in the vertical direction effective stresses are acting. So I can write force due to effective stress will act something like this, first thing. Second thing, in this direction the water is flowing from A to B, so in this direction we have seepage pressure. So force due to seepage will be occurring, force due to seepage pressure or seepage force will be occurring. We can find the resultant. The resultant will be your FR. This is known as resultant force. Resultant force. This we can easily determine. So what is the value of this resultant force? So this resultant force, of course, in kilonewton can be given as under root of force due to effective stress square plus seepage force. I can write the seepage force which I calculate either in per unit volume or using the given volume. So I can write seepage force due to seepage or seepage force, both are same. Okay, seepage force square. So like that, in kilonewton per meter or kilonewton per meter means for 1 meter length of the sample I can consider, 1 meter width of the sample I can consider, or better in kilonewton we can estimate this one. So this is the force or the resultant force which is acting in this soil element. Clear? So like that we can discuss. So in this lecture I have discussed about the resultant force which is acting in this soil sample if the water is flowing. We have estimated the seepage pressure, direction of seepage pressure, seepage force per unit volume, and we have seen how the total head, pressure head, elevation head, hydraulic head, piezometric head are estimated. Everything we have discussed, and we have seen how the datum is considered and all these values are calculated. Okay, so this was the discussion for seepage analysis. Thank you.